computer. All right, I guess we're recording. We're ready to roll. So what we're going to do is we're going to program our CNC project number 3. I believe you just turned in the drawing before class, or a lot of you turned it in right before that, but so you have the model. And what we're going to do is we're going to plan together. Sound good? So you modeled it. What size stock would you machine this thing with? Leslie says 1.5 diameter. Yeah. Oh, it does say it on the drawing, does it? Does? Oh, yeah, look at that. It says it on the drawing. So we're going to use 1.5 inch diameter, right? And we have to, if you remember last week, just do this. We have our stock in there. What's holding onto the stock? You say the chuck. So that orange is a chuck. Fair enough. So we need to come up with a stick out length where you're not cringing when the part off tool is this far off the chuck. Sound good? Because I don't want that to happen. Now, if we look, this thing is what? 3.75. The part off tool is 1/8 of an inch thick. So right now, no matter what, the part off tool has to come to 3.875 back. I say we at least give it 1/4 of an inch plus that extra 1/8 that we have. So let's pull it out to 4 1/4. Does that sound good, everybody? So when we set up on the lathe, we're going to pull it out to 4 1/4 every time and touch all of our tools off on a 4 1/4 stick out. Cool? When you go set it up. So we know that right here to right here is 4.25. Whoop, right there. Fair enough? Now, then our diameter, 1.5. Everybody good? Okay. Now, looking at this part, what type of tool paths do we need to create in order to make this happen? Think about it. We got raw stock. The part is somewhere inside the raw stock, right? It's going to be actually how far inside? What do you think? Name a number. 25 thou. How does that sound? Inside the stock. So we'll put the part here. This is going to be kind of the part. Fair enough. So we're going to have about 0.025 from that raw stock cut to the actual face of the part. Doing good? What do I do first, do you think? Face. So we're going to face it first. Sound good? We'll face. Then what do you think? Rough turn. So we're going to rough it out. So we're going to rough it. Sound good? Then what should we do? Finish turn. Good idea. So we're going to write finish turn. Now, the part's sitting there spinning. What's missing? The grooves. So we should do a grooving operation. Sound good? You good? Then it's on bar stock. How does it become a part? We part off. We're going to part it. Alan, can we borrow that part off tool? There, over at the, you said there was one over there, or you didn't tell me that. One of the techs from over there said that there's a part off tool we could probably borrow. Is anybody in here that said that? It was maybe one of the lab techs. Then that maybe it was Jake. It was Joe that said it, huh? Yeah, it was Joe that said it. Do you think that to be a possibility over there, or do you don't know? Okay, cool. We'll get it figured out then. So I just knew you worked over there too, so I was going to steal your tooling. So last but not least, we're going to part it off. Fair enough. All right. So with that, you can't deviate from the tools. We have the specific inserts already, we have basically our C and MG, we got our V and MG to finish. We've got our grooving tool with a certain thickness. So where do you get that information? Do you remember? Well, you were given it, right? So last week, if we were to go to CNC Project 3, there's a document. It's right here. This is the order we're going to basically be doing the cam in. Fair enough? So your tools, the numbers are right here, and then right up here, it actually gives me the insert data in there that I need in order to fill out for masters. Cool? We're doing good. Okay. I'm going to go back to the PowerPoint probably one more time. and then I'm not going to come back. So what we're going to do, are Haas lathes programmed in diameter or radius? After watching that lecture, diameter. So we're going to pick a diameter coordinate system out of Mastercam. That's the D coordinate system. If you pick an X, it's a radius. I want to point that out. It's for machines that might be programmed in radius. They're really rare, but they have it just in case. So we're going to use basically the D coordinate system for diameter. And we're going to end up making sure that that gives us a Z and a D. Does that make sense? Z is along the length of the part. D is the diameters of the part. We doing good? It's really easy. This is 2-axis. And because it's 2-axis, we're going to go through the lathe post processor there. I could really program the whole part off that. It's a half of a profile where the Z values are really what they are, and the X values are the diameters. We're going to talk about how that works. Sound good? So we're going to work on making that profile out of Mastercam. And then we're going to, after that, we will then go through, add stock, and then create the tool paths. I'm not going to come back to the PowerPoint. I would probably watch the video over looking at PowerPoint slides. Cool. So when I come into Mastercam, are there any questions so far? And if you get lost, ask a question. Don't have me redo it for you. Sound good? Go ahead. Yeah, you should. You use the part to make that profile. Unless you want to sit there, you can do it either way. You could draw line by line, or you could import the part and have it make it. Your call. So there's always a hard way of doing something, right? You can do it that way. So check this out. We're going to go File, Open. And I'm going to go hit my computer, browse. I got to go find where I put it. I don't know where I put it. So it's going to be in Spring 24. That's definite. It's going to be in 335. That's an even better guess. And I'm just going to go for like 9. And I'm going to go find SolidWorks. I'm going to guess it's Lathe Project 3. And I'm going to press Open. Cool. I'm going to make mine shiny. Ooh. Okay. So literally that you didn't have to do that. But it looks better, doesn't it? You know what? 3 out of the 4 teams were using Fusion. 1 team was using Mastercam. Thought that was interesting. You can bring it's tools. You can bring whatever you want. Yeah. I'm not allowed to really tell, but Mastercam. But you don't know really who. I'm not allowed to say the name of the winning team because it's debuting on YouTube July 1st or something like that. Yeah, I think that's what it is. So. Huh? They got lots of, oh yeah, especially with me, I'm all over the place. I don't know if they liked me or just thought I was a weird Californian. We'll see. So a little bit different there. Probably both. So check this out. So where do we, is everybody doing good? Where do we set up over here? Where do we set up? Yeah, planes. That's what I was trying to. So we're going to go to planes. And when you have your plane here, if you look, we don't have a regular Cartesian coordinate system, right? We have the D positive, Z positive. But don't do this right now. I'm showing you some stuff. I'm going to make your life easier. Trust me. I'm going to try to explain it. Don't do what I'm doing at this point, though, because there's a better way to do it. I just want to explain how it works. So when I go to D positive, Z positive, and I go to equals, do you see down here at the bottom, this term changes to a D positive, Z positive. It's a glitch. Sometimes it goes away. Don't freak out if it goes away. It's weird. So with that, I'm actually aligned up pretty well right here. Now, if you had it lined up really well, don't do what I'm doing here again. I'm going to show you from the scratch how to do this. I'm just trying to show you how this works. If I went to basically model prep, wireframe, and called turn profile, what do you think I'm going to select? The part. I'm going to hit in selection. You do a spin. Its tessellation tolerance is 1 thou. It's good. It's how close it follows it when it spins it. It'll be fine. And I want an upper or a lower profile. What do you think? Upper, because that's positive D values or positive X values. Lower profile would be negative. So I want an upper profile. And when I hit check mark, I probably should have done that on another level so I could show it to you hidden and not. You see that? So I'm going to press Control Z real quick. Get rid of that. I'm just going to go to 2 real quick and just show you wireframe. That way you're not putting it on the same level. You can hide it. You don't want your model and your wireframe on top of each other. So watch this. Turn profile, select, in selection, there, and I can turn off. Oh, I did the whole profile, didn't I? But, oh, no. It did half a profile, but it spun it this way. Does that make sense? So this is why I'm showing you this, because chances are it's not going to get your D and your Z's correct unless you align it. That's what I wanted to show you is the align function. So when I go to right here now on home, I hope I didn't confuse you. Analyze entity. If I picked right over here, you're going to see the D and the Z, Z0, the D is negative, basically 1.45. So if you look, I'm not really at the right location, if that makes sense. Watch, when I can also analyze position. Right there, my D is 7.5 and my Z is 0.187. Does that make sense? So I'm backwards on my D and I'm 90 off. Does everybody understand that? So I don't want to use the default planes D and Z is what I'm getting at. I need to align it first. Is everybody doing good? So what I'm going to do first is I'm going to just delete, because this is the wrong geometry. So I'm going to go ahead and draw a box around it and hit delete so I have 0 on my wireframe level. Does that sound good? And I'm going to go back and show my model. Well, if you want to align it correctly, if you didn't draw it correctly in SolidWorks, if you didn't draw it down the Z axis, that's what you'd have to do. Draw it down the Z axis and have the diameters out of the X and it'd be all right. But I didn't do that. You probably didn't do that either. I don't think so. So maybe you did. Who knows? It's like a 50-50 chance or less than that. It's like a 33% chance because you have the 3 planes. So what you're going to do is you're going to do something called the turn profile. Does everybody see under model prep? It says align to Z. Aligns a solid body for a turning operation to a new WCS or existing construction plane along the Z axis. We're going to create a new one using align to Z. So this is something you'd probably want to do. So we go to align to Z, and I'm going to call it Lathe WCS. Oops, not Z. There we go. Lathe WCS. Sound good? Now, which is my Z orientation? I need to basically pick a circle. Any of these circles will work. Does that make sense? So I'll pick one. Bloop. Now, is that the right way? It's opposite 180 out, right? Do you see this button? Move it there. And we'll transform it later. We're just aligning it right now. Sound good? So when I hit check mark and I go to my go to my planes now, does everybody see it says Lathe WCS? So I'm going to do that again for you. Sound good? Delete that one. What's in use? So I'm just going to show it one more time so you align to plane. What I'm actually, there's another way you could do it too. I could just form it to plane, and I could pick my D positive, Z positive right there. That'd probably be the best. You just pick D positive, Z positive. You do that, transform it to that off of that by flipping it. Check mark. That's what I would transform it to a D positive, Z positive, because you see what it does down here now, everybody? It gives you the D positive, Z positive. So I wouldn't just put it on its own plane. I just transform it to that D positive, Z positive. Now, when I click on it, does everybody see don't look at this. It's Mastercam uses that XY plane for shading. And if you look, we got our D positive, Z positive down here. This is aligned with that. That's what matters. Does that make sense? Is everybody doing good? Good? Perfect. All right. So now what am I going to do, you think? Now that I got it aligned correctly, what am I going to create? Those of you trying to do it, I'd probably watch this and do it later. So I would create my spin profile at this point, right? So when I do that, I just make sure that it's very important that this is W, C, and T when you're creating this geometry. Then I'm literally going to go, whoops, I'm literally going to go to model prep, or it's wireframe, turn profile, that face, that check mark, upper profile, check. And my level, I now have a half of a profile. Is this making sense? And let me make sure my half of my profile works. It's at the right location. Sound good? So when I go to home, this is one of my favorite buttons, analyze position. If I go down here, 0 and Z is 3.75. We're doing good. I just got to shift my Z, don't I? Because it's in the back. But check this out. If I do analyze position again, it's underneath dynamic position. I come right here. That's 0.375 and 375. So we're doing good. The last one that I would double check under position is back here. This should be the major, this should be the diameter of the 480 or 1.48, right? 1.480. So we're good there. And the Z is 25 thou because that's the chamfer. We're doing great. Is everybody okay so far? Do you understand that we are now aligned with our geometry? Are you good? Yes. So it's underneath home, analyze, and underneath dynamic right there. So the thing is, though, is my home location in the right location? Now we're going to put it at the front of the part, right? So can I delete this one yet? There we go. So I deleted the one I created that was wrong at the beginning. You good with that? Just because I didn't want it there. So what I'm going to do is I can't change remember, this is the world. You can't change the world. You got to duplicate it. And then you can slide it to wherever you want, like to right here. So I added the 3.75. Don't confuse yourself. It's in the X because it's off of the Cartesian coordinate system thing up here. It's weird how they do that. Is it not? Seems a little bit odd. It's shifted off the world is what it is. So everything's based off the world down here. Why? Does that make sense? That's why it shifts at 375 in the X. Yours might be Y or Z, depending on how you oriented yours. I don't know how you oriented yours. You good on that? So if I make that equal, I'm going to call this G54 or WCS G54. We good? Do you have any questions so far? Like so basically all I did was I got my geometry ready in terms of my home location. Yes.
Here, bottom left coordinate system thing, B and Z down there.
Is it blanked out?
Bottom of the string.
Right here?
Yeah, that guy. That's still an X.
I wouldn't worry about it, but it's probably an X, Y, and Z because you didn't put D positive, Z positive at the beginning. Sometimes it defaults back, and I don't know why, but you should be good. So now, one thing that you don't need, and I don't want you accidentally clicking on it, is this line. So I just want everybody just to get rid of that back line because you could accidentally pick part off at the bottom of this line instead of the top of it, and things go bad with that part off tool. So we're just going to go delete right there. We just need to pick a point on the back. Sound good? How we doing?
So did you set for your phone? Did you set the G54 as the WCS?
Oh, I just call it GWCS G54 just to kind of name it that. I just renamed it. So So now that's what we're going to be programming off of. Our goal, everybody, was to have a wireframe that has a position back here of negative 3.725 because it's before the chamfer. You see that? So, right, and then the 1.48, you see that? If I went ahead and I clicked that endpoint, it's 1.43 and negative 375. So I'm good. Does that make sense? Good, John? Cool. Just quiet. Then right here, what should this point be? 0, 0. Do you agree? All right. So if you don't, you can still program along on your wireframe and we could probably move it later. Maybe. I don't know. You should be able to. All right. So I'm not going back to the PowerPoint, but that's all we pretty much, the next step would be to basically add a machine. That sound good? Do you have any questions at this point? What's up? We're good? Okay. So toolpaths. In order to get a post processor in here and make toolpaths, what do? I got to go to the machine tab and I go to lathe and I'm going to go to manage list because you probably have nothing in your list right now. You probably have 2 of them now, right? Which one are we not picking? MM. So we go to there, we go to add, check mark, and we now have a lathe right there that we can select. Is everybody good on that? So when I pick lathe, machine group 1, I like to right click, rename, I'm going to call it lathe op number 1. Cool. You don't have to do that part, but that just makes sense to me. Now, let's build some virtual stock. Sound good? So we open up this little properties thing right here. You see that? And we click on stock. Stock setup is also up here in stock. But there's a stock model. There's also a stock setup up here, but I'm going to just go here. And do we have a left or a right spindle? Left spindle. Let's go to properties. It is 1.5 OD. Do you agree? How long is it? I want you to go 5 inches right now. I don't want you just to do 4 1/4. The reason is it's going to look funny if you do 4 1/4 and you have a chuck because it's going to like not be holding on to anything. You could do that, but it doesn't matter really. It's just virtual, but bring it back to 5. Does that make sense? So we're going to bring it back to 5. Position along the Z-axis, everybody. When I see it, look, see it's building my stock out there. What position is it along the Z-axis? What do I do? No. Right here. This 25,000. So watch this. You see my stock up here in front of my part? When I add 0.025 tab, it puts the stock in front of it. So when I face off at Z0, it qualifies the part and machines the part, not the saw cut or the part off tool surface that the last person who just parted one off did and you pulled it forward. You don't want their part off tool surface finish. It looks horrible, especially with our high speed steel one until we steal one from Mustang 60. We're going to give it back, so we're going to borrow. Then if you bend it, we'll have to buy them one. I told Brian to order one. I don't think we got one. I haven't seen it. I haven't been around though. Is everybody good with the stock here with this setting? Does that make sense? So when I hit check mark, what else should I probably put in there to make sure I don't hit? Chuck jaws. Yeah, so we're going to go to properties. We're going to go to parameters. What's the diameter of the chuck jaws? If the stock is 1.5, what's the chuck jaw diameter? 1.5. Now, do you see where they are? They're up there in front of my part right now. You see it slowly building it? That's not going to be good. No. So where's the Z? Is it 4.25? If you look, it's negative, isn't it? See, it's back. So it's negative because it's all based off where Z0 is. Is everybody good with that? So check this out. I got 4.25 negative and a 1.5 inch diameter for my chuck jaws from the Z0. Now, back to my geometry for my chuck jaws. We're going to use their default ones. Do you see this? It's a parametric spreadsheet. You have a step on the jaw, you add a step. You don't have a step, you take one away. And it basically steps up some generic jaws for you just to stay away from. So what I normally do is I give it like 25 extra thou on my jaws right here, just in case, or 10 thou. Sound good? So I'm going to leave the default. We're good. I've never measured the ones we have. They're fine. So you're not going to get back there over the jaws. Sound good? If you were, we would measure them. So we'll hit check mark at this point then. And then one last time, check mark. What that does is it puts some stock in there. See what I mean about the stuff? Now, that even still looks pretty sketchy, but we'll be okay. Sound good? If you're pulling out and you have about this much left, you only have like this much left, what do you probably do? Probably put a new 3-foot stick in and put that one back in the strap for right now. Sound good? So if you don't feel comfortable with how much you have gripped as you pull it out, one of you will have that, some of you will have that issue, depending on like where we cut the bars. So you got like 3-foot bar stock. I don't know what part number it's going to be on that bar, but it will be an issue. So at this point, I'm ready to, you could actually shade your stock right there, if that makes you happy. I don't know. I like it. It's going to make me happy. Sound good? I'm going to keep it like that. So now we're ready to make toolpaths. You ready to make toolpaths? I am. So check this out. We no longer have, well, we do have why do we have a milling toolpath thing in our lathe post-processor? We could have a y-axis lathe, and I will demo how y-axis lathes are programmed next week. Sound good? So we got to learn the basics first. Then I'll do a simple part on a live tooling one to show you how to bring in milling and turning together. And that'll be it for master camp. So we are not going to go to milling for this one. We're going to go to turning, and look at turning's actually really cool. There's only like a couple tool paths. I'm going to show you the dynamic turning later with another part, dynamic rough. It's pretty cool. But for now, we've got rough. We've got finish. We've got drill. Do we need that one? No, if we had a hole in the part, we would. We got face. We got cut off, which is part off. We got groove. Then there's a dynamic rough, which I'll talk about later on the last day when I show you live tooling. Then there's something called threading. We're going to learn on Thursday in lecture how can cycles work and how that generates the code for the can cycle in the thread. Sound good? Mm-hmm. So then it's got a plunge turn. If you had a round insert, it's pretty cool. It's got this contour rough. It'll actually rough like on like a bunch of finishing tool paths. It's pretty cool. It's got so it's got a Sandvik add-in. I don't even know what that is because Sandvik bottom. Cool. Then it's got custom thread. Ooh. And then manual entry allows you to just put some code in there, and then point, you can tell it to move to any point. It'll post like a G0 or G1 to move to those points in the lathe if you had to. Then they have machining cycles. So if you wanted to post can cycles that the lathe puts out, like a G72 or 76, it'll post in can cycles instead. Pretty cool. Lowers your amount of code. So that's what it's got. We'll talk about these C-axis ones that are also made for live tooling later on. So let's use the first tool path called face. I might need to get my water bottle at some point. So, but for face, we now need to set up our tools correctly. There's four different types of tool holders. They're right there in front of me. OD rough right. OD rough left. What's the difference? Right hand tool, left hand tool. Ooh. So back turning, regular turning. Cool. OD, oh wait. Rough right. Does anybody know what this type of tool is? This is an OD tool, you think? Or what do you think? If they have ODs, what else do they have? These are boring bars. So this is a right-hand boring bar. What's this one? Left-handed boring bar. Doing good? Now, these are just sharper tools. What are the sharper tools you have to do? Finish. These are like facing ones. These are grooving tools. what do you think we're going to use? We're going to build our own. We're going to build our own off of tool 1 though. How does that sound? So double click on tool 1. Used to be double click. There it is. Mine's just super slow. Now, let's say we have our catalog. Select catalog. Oh, shit, this is great. Well, that's on video. So what we got, we got ISCAR, we got Kennametal, they got catalogs. You know why? They're all the same inserts. Like they're all the universal designation. So, oh, look, there's Sandvik. So if I open that catalog, I hit get insert. Oh, geez. It's like literally the exact insert with the chip break or anything. But we know about inserts. We're engineers. So we're going to build our own. So what are we using? If I went back over here to this and I zoomed in. So for roughing and facing and turning, we're using a CNMG 432B. That's all we need to know. The shape, size, relief angle, nose radius of our insert. Sound good? Now, so when we go back to Mastercam, I don't even care about the inserts here. Delete insert. Whatever. I don't even care about the catalog. I just picked one. But what I care about, I'm going to just call this CNMG 432 because that's the one I picked, right, originally. Now, how does that work? Well, number one, it's a C. Is everybody good in that? What's the next letter? N. It's the relief angle. Look at that. We learned about this. What do we have? N. The next one, M, was basically the tolerance. Do we care about a tolerance on an insert in a cam system? No, we're making it perfect, right? So we don't care about the tolerance, so it's not there. G is the mounting method. Do you remember that? We have a double hole. You know why? We have a neutral insert. We can go both ways or both sides. So we have a G. What was the 4? Does anybody remember? It was 4/8 for the inscribed circle. Oh, man. So the 4/8 is a half. Last time I converted my fractions, right? Now, the thickness was in 16ths. You remember that? So 3/16 is the thickness. 4, 3. The 2 is in 64ths, right? So 1/32. So we just set up the nose radius to do cutter comp correctly. And the insert shape and size. Is everybody good with that? Well, that's not all. Oh, wait. So if we didn't have that insert in an OD holder, everybody go to the turning one right here. There's turning, there's threading, there's a grooving holder, a boring bar, a drill, or a custom. Ours is set up in turning. Does that make sense? Then the holder is either right or left. Do you see that? You can actually build the holder. So we have basically, we're set. It's a 5-degree holder. You don't need to touch the holder. Is everybody good there? Don't touch the holder. Just make the insert right. You would care about the holder if we were worried about it, shanking it out on the back of the part. I don't care about it. On this part, we're not going to shank this one out unless you accidentally do the second operation with it. Hopefully you pick to the other tool holder. We'll talk. It's on video. So you should be good. So now, it's not always so now we got parameters. So this is going to be our tool number 1. Is everybody good with that? We're going to use the power on that lathe. So I'm going to rough at 12 thou. Then we're not plunging into anything. So in Mastercam, they have a plunge rate if you're doing some dynamic turning or plunging with like one of those neutral ones. So I'm going to make this 12 thou as well. Now, spindle speed, I could do CSS. What does that stand for? Or I could do RPM. What do I do when I'm turning on a lathe? CSS. So with carbide and aluminum, we're going to run 650. And we're probably going to max that thing out by the time it hits the diameter, like about 1 inch. It'll be spinning all the way that thing can spin. Now, I don't care about these toolpath parameters down here. Don't change any of that. And we need cutter compensation. We'll have that on the next page here. So actually, we'll have that when we program. I'm sorry. Realize we're not programming. We're just setting up the defaults. So when I hit check mark, I'm pretty much ready to go with my tool now. I built a tool that I can use now for basically facing and roughing. It's my tool number 1. It's tool number 0101, right? And it's 1. Don't worry about stations. We only have 1 station in this machine. Some machines have dual heads, dual stations. So now the feed rate, is it going to be inch per minute or inch per rev? Inch per rev, G99 inch per rev that lays feed and chip load. We're going to run that 650 CSS. What's our maximum spindle speed? It's 2000 on that lathe. So that's what I do. I set up my tool and my feeds and speeds in my first tab. Look how easy the second tab is. What I would hit is use stock. You know why? It knows where the top of the stock is and where it's at. If you don't use stock, guess what you have to do? You have to draw a rectangular box by selecting 2 points and it'll face within that box. Does that make, so like I would start here and down there and it would face in between wherever I started and stopped. But we have stock, it recognizes stock, so use stock. Cool? So we are going to, this is 25 thou. I was going to do 1/10 thou finish pass. Sound good? Actually, I'm going to leave 5 thou for the finishing tool to come touch. Just made that up. Program on the fly for everything is way more fun. Way more. So when I hit check mark, what did it do? It came in and it actually shortened my stock. Do you see that? The stock got shorter and it left 5 thou. It did 1 pass. Yeah.
On the center screen, the second tab. New stock. I have 3.75. 0. That's how we set it up.
You might have your Z in a different spot.
Not B and B.
You, Bobby, just don't have you don't, yeah, so we can shift that later, most likely.
What do you have for your entry amount there?
Where's my entry? 0.1. That's just the default. It's staying 0.1. So that's this line right here saying 0.1 away from when it first starts cutting. Is everybody good on this? So do you see where my line is? Watch when I press start or when I press check mark, it'll go back and show me what this toolpath did to my stock. That makes sense? So watch, boop, see how it disappeared to it. It got shorter. We good? So we just faced once. We're good. We kind of qualified a surface. We left 5 thou. What do you think we're doing next? We are going to rough turn. Sound good? And so technically there's only about 20 thou up here. So we're going to rough turn in 2 segments. We're going to rough turn here, but we can't dive into here with our tool holder. We'll shank the back side of it. I do that on purpose to show you how you got to kind of sometimes switch tools to rough. So when I go to rough, I'm going to pick the chain, but I don't want the whole chain. You see that? I don't pick, if I do this, it picks the whole thing. You see that? So I'm going to press the red X. I'm going to pick partial chain, and I'm going to rough from the nose to right there. So green start, red stop. Is everybody good? I'm going to rough out all that. I'm going to rough out all this material right here. Basically what I'm doing. Now to do that, after I've selected my geometry, I hit check mark. Did my tool change? Not yet. Not yet. Not on the next one, it will. So we're going to use that big stout tool to rough as much as we can off of this. Did my feeds and speeds change? No, but that's 10,000 RPM. I obviously didn't set that right in my tool information menu. So I got to fix that. If you put 10,000 in there, don't care. It's just going to redline at whatever it redlines at. It's kind of like if you drive your car, you just keep flooring it. It's going to stop at some point. It's not going to blow up. That's how you shift, right? Yeah, man. That's how I shift my GSXR. It's actually it's really cool. It's got a little strain gauge on the shifter, so it cuts the ignition timing and just it's insane. I've never had anything like it. So now rough parameters. I got an adrenaline addiction, just to let you know. So at this point, we are not going to rough at 100 thou depth of cut. You know why? You might stall the lathe. It's like, it's only 7 horsepower. The Baja car is more powerful than our lathe. So like literally, we're going to go 50 thou on that. Sound good? That's actually going to push it quite a bit too. That's 100 thou in diameter, 50 thou depth of cut. The other one was 200 thou in diameter, right? So this is 100 thou taken off per diameter, per cut. Now, do you think we should leave some stock if we're roughing? Yep, so we're going to leave 10 thou in the X and the Z. The lathe is cool. It allows you to leave it only on the diameter or only on the lengths in case you're going to maybe just finish grind something. So you can, like that. It's pretty cool, right? So you can come up the walls and only leave it on the diameters. Or you can leave it in both, which we're going to do in this example. So now, I also want to, no, I'm good. I'm good on my lead in, lead outs. Does everybody see we're using computer though for cutter comp? So when I hit check mark, well, look at my stock. It went away and it looks like my part now. Somewhat. It's still missing some stuff. Is everybody doing good? So 50 thou depths of cut. It comes up, it roughs around. We're ready to go now. Now, what we haven't done is we haven't come back here and rough this out. Now, I also want to split that up because I can't it's something called undercut. Let me show you this on the last toolpath I just did. I'm going to show you I can really mess this part up. So there's something called plunge cutting. It's down here. Do you see plunge parameters? It's skipping any grooves right now that are negative that it can't get into. If I took that off on both ways, X and Z, I hit check mark. Oh, it tells me. Oh, I collided again. I collided again. So what it's trying to do, look, it's trying to drive that down, you see? That is not good machining practice. Does that make sense? So you make grooves with a grooving tool on a lathe. So you want to take plunge off for the first one, but not for this next one when we're roughing. You know why? The next one, it won't plunge down into here unless you take that off on the next roughing tool path. We ready for this? All right. So the next one we're going to do is another rough tool path. Bloop. Now, we want to start right there, and we want to end right there. We want to rough out this little bit of material before we come in with a finish pass and all one smooth move. You good with that? So what I'm going to do is I'm going to hit check mark. My tool has changed now. They actually have one that's very close to the final one that we're going to build, and I'd recommend just building it off that. Or what you could do is right click, create tool. Let's right click and create tool from scratch. Sound good, actually? So I'm going to create tool. Is it turning, threading, grooving, boring, drilling, or custom? Turning. So now I select that. I'm going to write over here the insert name. I'm just going to write VNMG332. Fair enough. That's what we're using. Does it say 432 on your handout? Or they're 332. I'm sorry. So the handout says 432. We have 332s. That's a mistake. Sorry about that. So we have a 332. What really matters is the nose radius. If you accidentally did 432, it's just a little bit bigger. You won't notice it in the cutter count. So to make this a V and MG, I got to take it off a C, don't I? And I'm going to just drag this down to the bottom of the alphabet. Oh, it's not in alphabetical order. There it is, V. They leave all the diamonds together. So V, N, M is the tolerance, don't care. G is the mounting, we're good. Now it's a 3, so it's 3/8. Right? Then 3 is the thickness, 2 is a 1/32 nose radius. We're good to go now for the insert. The holder is actually the -5 will work. Let's leave that -5. We'll be good. The parameters, it's a very thick insert, or it's a very thin insert, not thick. So what does that mean on feeds and speeds, do you think? If you don't have as tough of a cutting edge. We're not going to run the 12 thou with it. I would run more like a 7 thou with that thin insert like that. If you looked up the values, they would recommend that from the manufacturer's data. It would be smaller than the CNMG, I promise you. Now, 650 spindle speed, constant surface speed, 7th thou chip load. I don't even see where it doesn't even show max RPM on this one. You'd think it would have that setting in here. So when I hit check mark, I've got my lathe tool 2 now. Does everybody see it? Let me see what insert they have on this one, or what holder they have on this one. See, they built it a little bit different in that E is 52 degrees. We need to match that, just to let you know, so it doesn't sound like it's going to crash, or so it doesn't look like it's going to crash. So let's come up here. Let's go to edit tool, and the holder. Did they build their own? Get holder. So does everybody see the problem with this holder? It's a DC. We need a V holder. Do you see how it's holding it funny? Like it. So the real way to do it is just to come down right to this one, since it's already got it. OD finish right. We're gonna right there. We're gonna edit that one. And it's literally got the VNMG 431. You just change this to 3/8. That's all I did was just change that to 3/8. And then I went to the holder. You see how it had this E value. I couldn't find how to find that holder with that. It is the MVG. It is the one I told you to get it. Mine didn't update my pictures, my problem. So I went and grabbed it again. And then the parameters, let me just fix that again. 7th thou chip load, 7th thou plunge. It's tool 2. So you can update the default tool 21 in Mastercam to tool number 2, and then basically give it the values. It's being videotaped, so I know you could go back and figure that out if that doesn't make sense. Do you have any questions for me right now? I'm gonna right click on that. Do you see how the holder looks different from that to that? I built one off with a C holder, but I put a V insert into it, and that's not a good idea. Is that you good? So I'm gonna write. I'm actually so I don't. It was the tool designer, so I wanted to get rid of that one. No, I just won't select it. We'll be fine. So back to my rough parameters. We cannot rough at 50 thou depth of cut with this insert. You'll hurt it. You'll hurt it. So we're going to do 25 thou. We're going to leave a little bit of stock. Now, if you don't change the way the lead in and lead out is, you're going to crash the tool, and it'll tell you that. So can I show you it crashing first and then go back in and fixing it so you can see the bad way and then the good way? So there's these lead in and lead outs right here. And the lead in and lead out has an entry vector. Do you see that? It's at 0, 90, 180, 270. You got that? Like the robot. So literally right now on a 180 entry angle, that's going to be bad. So when I go and I hit check mark and I change my plunge parameters to plunge so it's going to cut something, it says, warning, collision with stock. Continue? Sure. Check mark, check mark. Oh, so when it's coming in, it's trying to plunge in and it's colliding with the stock and the holder. That's not going to be a good day for you. So, right? So what we've got going on here, let's go back to parameters. In order to fix that, I go to my lead in and lead outs and fixed direction. I want to be perpendicular in. And so it's going to come in at the curve and go perpendicular into the curve, drop down, and then come out. Instead of giving it a fixed angle, you allow it to just go perpendicular to it. Is everybody good with that? So that's my lead in. I don't think I need to worry about lead outs if it gives me, because the lead outs are 45 by default. It comes in and it goes out like this. Does that make sense? So I think we're good on that. But I do want to extend the end of my contour so I have a nice machine surface for my part off tool to go into. So I'm going to extend it 150 thou. No, that's 1 inch. 0.150. It would have crashed into the chuck and told me that. So when I hit check mark and check mark, do you see I didn't get a warning that time that I'm crashing my tool? That's usually a plus. So, and do you see how my part's starting to look like my final part? Yeah. I just left 10 thou on that one. So you can see it. You see how it's not on the line yet? Okay. So we are now ready to take that same tool and finish. There are two ways to do finishing. I'm going to show you the way I would do it if I was doing it for a part. Because I have to be able to take the finish tool and go woo, all in one pass. The problem is if I have plunge on, what's it going to try to do here when finishing? Right? But what's it going to need to do right here? Plunge. So I'm going to create my own wireframe layer for finished geometry. I'm just going to get rid of these things. Does that sound good? Sound good? So to do that, bear with me a minute. I'm going to hide my tool paths because I haven't been doing that. It looks horrible. It's lines all over the place. So we go like this. We go like that. Okay. I'm going to go to my levels and I'm going to write 3 and I'm going to write finish wireframe. Sound good? Now with that, I'm going to turn off the old wireframe and turn back on my sweet looking model. We doing good? All right. So what do you think I'm going to do to get me some geometry real quick? I'm going to go to that wireframe. I'm going to do turn profile, click on that in selection. It's going to spin it. There we go. Check mark it. Go back and hide that. And I don't need for my finish tool path. Well, number one, I don't need, let me show you. I want to go to the end of my chamfer. Sound good? I don't want to undercut down into that chamfer. So there's this really cool tool under wireframe and under modify length. What's the length of the chamfer back there? Do you remember? The chamfer's 25 thou. So if I go 0.025 and I click on that line, what did it do? It lengthened it so it's at the same stopping spot because I don't want you to accidentally plunge down to that. Probably wouldn't notice. I would notice. I would notice. I started looking at people's parts today on the cart. I noticed a few things. I was like, so now I noticed Mo's not here. I was going to give him a hard time. So I was looking at his part and I was going to say something about it, but now I'm not going to. Go ahead. So Control Z, Control Z. Check this out. When you lengthen in the wrong direction, it's because you're clicking on the wrong side. So Mastercam uses this line. It picks the midpoint of the line. If I go a little bit to the right of the midpoint, it's going that way. Control Z or escape. If I went ahead and I went a little bit to the left of the line, it goes that way. That's same when you pick your tool paths. It's where it starts. So you gotta want to pick on the side where it started, where it's closest to. It's kind of weird, huh? It's crazy. There's these little things that if you don't remember how they used to do it, that's how they used to do it. So now when I hit check mark, what am I going to do with this one? Delete it. I don't need it. Now, what else am I going to delete here, you think? I'm going to take basically my window. Did you chamfer yours up here, by the way? If you didn't, you need to chamfer it in Mastercam or bring it in with SolidWorks, one of the two. But like if you had sharp corners right here, you just use the chamfer right here. You go chamfer and you put the 10 thou chamfers that the drawing said that added on there. That's gonna make so you can chamfer it with the grooving tool. Does that make sense? Because your wireframe has a chamfer, the part will have a chamfer. So you just use that. You know how the chamfer entities works. You got a square corner, 1, 2, chamfer. So, but I don't want, let me go to my view. So I can make this easier. I'm going to go to my top view, which is what I'm at right now. Whoops. And I'm going to drag a box around all that because I don't want any of that. I don't want that. I don't even want that, or that. All I want is one line wireframe between that and that check mark. Do you see what I'm doing there? Now, if you wanted to make your part a little bit smoother, you could put a little fillet right there. I don't care. It would work. I just want you to learn how to program a lathe. I don't care if it's got a fillet or a sharper corner in it. Sound good? Then you can go make stuff. All right. So all that work just to get a finished toolpath wireframe. Now, what I'm going to do is I'm going to go back to my turning. I'm going to go to my finish. Sound good? So when I hit finish, I go from there to there. If you didn't want to spend the time doing this wireframe, you would have to make one finish pass like we did roughing for right here. And then you make another one for right there. One would have no plunge, that one would have plunge. But then I think a smooth motion of the tool is way better than coming around, stopping, coming back around and finishing again. So a lot of the times you just draw external geometry to make your cam work. Now, when I hit check mark, did my tool change for finishing? No, but my max RPM should be 2000. So I'm going to run 650 surface speed. I'm going to run a 6th thou chip load for finishing. You can run 7. I probably wouldn't be able to tell the difference. When I go to finish parameters, I'm not leaving any stock. I could do multiple finish passes if I wanted to. I could do 10, 10, and 10 if I needed to. I could go to my lead in and lead outs, and I want to extend the back a little bit, that 150 thou. That way I have room for my part off tool just to come in. I don't really need it. I could just part off stock, but it's just something I've always done. Now, I believe the default lead in and lead outs work fine on this one. So when I hit check mark, I want to go to plunge parameters and make sure that's turned on though, so I can go ahead and finish the little radius in the back of the part. Then I'll hit check mark there. I'll hit check mark. And it does one finish pass. It comes in and comes right around and comes off. Yes. I left it as perpendicular right there. It wasn't on that? Well, let's go see. It was on the default, whatever finish has, huh? So it comes in at 180. 180 is perpendicular. Because what? Because like, watch, because the so the lead in is 180 in, which is perpendicular. No, we don't need to do that one because it already is technically. And the lead out 45 seems to work real well after it's done. So now it did one finish pass. Oh my gosh, there's my geometry, but there's my toolpath line. Let me turn off that stop. Why is it doing that? Can you explain that on a final exam? Anybody? Wait. Let me turn on my stock again. Oh, no, that's, hold on. Wait, but when I shade the stock, it matches the line. But my lines are not there. What's going on? Who am I going to put on the spot since no one wants to say it? What's going on? Cutter compensation. Look at this. Did you want to have to calculate where that went as it comes around that radius? See it? Look at that. Then when it comes over here, look, it's undercutting up this side, overcutting up that side because that theoretical tool tip. You know how they did it back in the day before CAM? Charts. They had a theoretical nose radius. You're laughing. Watch this. Hold on. So I bet you I can find a chart when I search. How about lathe, cutter, offset? Oh, look at that cutter offset chart. Images. I'm just going to go to images. Well, hold on. It's in the, oh, you know where it is in your reading. Should have said that. I was in my reading, Mr. Jordan. Treon. So let me go right here. Let's go to the lathe workbook. I just want to show it to you. Just so you can get an appreciation for CAM. So where's programming workbook? How come I can't find it? It's week 7.
Sorry, what's the radius on the finish tool?
30-second. We all have 30-second ones. Here it is, programming workbook. So check this out at the end. Let me go find them. Tool nose compensation. Here we go. Theoretical tool tip. Where's the charts? Oh, wow. I just want to show you the charts of the struggle was real back in the day. Oh, there they are. Oh, that's the thread chart. Hold on. Gotta find them. Yeah, I wouldn't have read this much either. Control F, maybe? How about manually program TN 53? Oh, that's page 53 here. Hold on. Here it is. Tool nose compensation. Look at this. This kind of explains it right here. Here's a basic. They have charts with every angle, if that makes sense. So the tool nose radius calculator. So if I was doing a 31 tool nose radius, the X offset, and I was doing a 15-degree angle, I got to do the X offset at basically 0.0146, and then the Z offset's 0.271. So they had to use charts by programming by hand. That's just trig though, right? So back to this, that's why that's offset as it goes through. And right in the center of the basically context. Go ahead.
Sorry. So, is there a good way to edit the tool nose radius? Mine's looking a little different.
Yeah, definitely. I don't know if it would be the tool nose rate or that makes it look different. So, but if you needed to edit anything, you could go back to your parameters. You could go to your tool path. You could right click and you could edit tool. And right there's, oh, I messed up. Mine should have been 1/32. So I see what you're saying. You said you're over and you're undercut. Yeah. Oh, thank you. You caught me. I would have built the wrong part. But that looks more like yours, right? Where it's over.
Yeah.
Does everybody understand that though? Because you have to explain that on the final exam of why, we need that. So cool. So at this point, if we look at our stock, we'll go back to shade it. What's next in terms of our tool path? Let me update that rough. There we go. What do we need to do now? Groove in. So we'll go ahead. We'll take that out. Can I groove with this geometry? No. So we're going to go back to our level, turn on the wireframe, make a check mark, and turn off the other one. If you don't listen to me on or on geometry selection here, you're going to have a hard time with your groove. I promise you. It says one button where you have to click it. If you don't listen right here, it's gonna turn down the whole groove thing. It's gonna look horrible. So when we do this, when we go to pick groove, go find it. Got to be in turning for that, huh? When we go pick groove, check this out. You're gonna pick multiple chains, not chain. Tell you what, some people pick chain, then it messes it up because you can't pick multiples at that point. You have multiple grooves. You can pick multiple tool paths and do them one at a time, but you don't want to do that. So when I hit check mark, if this is a multiple groove, it only goes from there to there. And this button right here in chain allows you then to go from there to there in chain. You have to have chamfers on this or else you won't have chamfers. There to there, check. And then one more, there to there.
Is there a reason to do it in that direction?
I would have gone the other direction. I was just about ready to say. Why would you go the other direction? It's more rigid. You're going the other way, right? And when you're turning, you're going this way. I just picked the opposite direction I would have normally picked it from. Cool. It's going to make a part though. You're not going to know the difference on this one. If you have really thin parts. You start grooving on the outside, you work your way in. You want to remove the material on the outside towards the spindle that way. You don't want to start relieving it here with a groove and then relieving it out here with a groove because now we have less mass, right? You got to think about it like that for vibration. So I'm good with this though. I've got 4 different chains. I do not chain the top lines. It will turn the top lines. It'll look horrible. So when I hit check mark, I now have a grooving tool. Look at all the grooving tool path, and it only shows you grooving tools. Someone was thinking. So I'm just gonna, it don't matter on what tool holder you have, but we do have, if you want to set it up like we really have, we have a right-handed OD grooving tool. I don't care which one you pick. It just has to be OD groove right. We are going to then hit edit tool. What matters with this, what size does it say it is? Does it say it's 09 to, what does it say on? We have an 094, I believe. Instead of an 1/8 of an inch, our inserts changed. I forgot to change this document is the problem. I went from the 3. So everybody write down, instead of 125, we have a 0.09, basically 4. Just do that for right now. Actually do 0925 just in case. Yeah, just do that. If that number changes, I'll let you know. You just put the number, change it to 0.094. I think it's 0925. Now, it does have a really small radius on C. I think it's only like 5 thou. It's almost square. But there is a small radius to keep a stress riser out of it. If we'd have to look up on the package and see what it actually is. All you care about in grooving tools is they're not standardized, right? So I can't pick C and MG. I have to basically just make the little puck look exactly like my grooving tool looks. So they make ones that have angles, they make ones that have full radii. You just build it parametrically so it's just like your grooving tool. Now, so I'm good there. All I did was all I care about is the thickness and the nose radius. So it gets the chamfer right and the thickness of the groove right. That's all that matters. And the stick out length is important too. It'll tell you if you've tried to groove deeper than your stick out length, it'll say it crashed. So if it's saying it crashed, check your stick out length. That might not be right. So now at this point, my holder is an external right-hand holder. I'm not going to change anything there. My parameters though, it's not tool 44, it's 3. So make tool offset, station, everything, just make everything 3. We're going to run inch per rev. We're going to run constant surface speed. And we're going to leave the default 2.5 thou plunge and feed. I've made it 2.5 thou for both. So when I hit check mark, I'm now going to use tool number 3. My finished spindle speed, I almost like to do 500 RPM. I don't like to spin this very fast. I also don't like to spin the max spindle speed over 1,000 with the grooving tool. It starts to chatter. It's a real small tool. When you're running just wide open like that, the tool vibrates. So now I'm going to run 650 constant surface speed, but my finished spindle speed is just going to go down to 500 and just finish.
Spindle speed is 650, finish is 500.
Yeah. And it'll go up to, it'll use this 650, go up to 1,000. It's probably going to rough at 1,000 and then it'll finish at 500. We only care at the end for it to look good.
500 RPM.
That's RPM. Yeah. We're just going to run 500 RPM. So we don't go above that. So it roughs and it's up to its max spindle speed and then it slows down to finish. You all run in the same chip load, right? So we're good. It's 2,000 on the lay, but 1,000 for the grooving. Yeah. Yeah. Just gonna do that right now. It was a note on the drawing, chamfer all edges 10 thou. I'm pretty sure that was on the drawing. Everything goes single sharp edge should have a chamfer, except for the back has a 25 thou because that was on the drawing. So now when I go to groove shape parameters, what angle do I want to groove in with my grooving tool, you think? Yeah, we don't change that. You can change it, but we're not. So 90 makes sense. You could go in at like 48. That'd be weird. Don't do that. There might be reasons for that though. You might have some geometry. You got to, this is really good software that's been designed to make your robot do exactly what you want, your machining robot. So there's all these weird little options you don't necessarily need to change. So now we do want to change our rough, because what it does is it's roughing at 75% of the grooving width. That's a lot. I would do more like 40%. It tries to bury the whole insert while it roughs. So we're going to do 40% step over. Then we're going to leave 5 thou. You could do smooth or you could do steps on it, how when it grooves walls. We don't have any walls to step, so we're good. You could do a first plunge feed rate. You see that? So if you're having a hard time on the full width of cut, you could change that right here. That's cool. We're not going to worry about that though. Now, when we finish though, we're going to go to the next one. The finish step over. Basically, we're going to leave everything by default in here. Sound good? You can look at the different settings if you wanted to. You don't really need to change anything. When we hit check mark, it grooves it. You want to see what that looks like? We're going to go over here. The toolpaths, I just want to show you with the back plot. We're going to back plot that. Yeah, that works. Cool. All right, what's our last step? Oh, okay, we're going to part off. So we're going to shade that stock. We should get rid of it now so it'll disappear. Now, is my part off point on this geometry or my last geometry?
Last one.
The other wireframe, right, that I had because I extended it, the part off, extended to the chamfer value. Remember that? I need to be able to click on the back of the model where I want to send the part off tool. If I click down here, it's going to go too low. So I'm going to show my finished wireframe. You want to know how you could put a point back there if you didn't want to show the finished wireframe? Let me show you that. I could literally go right to wireframe point. Oh, I don't know if it's in D and Z. So D is X, so I think it's going to be 1.48, comma 0, comma negative 3.75. No, that wasn't the spot. That was up here. So it's off. Hold on. If I move this over here. It's off of it's off of back here. So we have the X and the Y. You see the X and the Y back there? You could put a point basically right there at that point, but I'm not worried about it. Let me just show you the real wireframe. So we go back to levels, that wireframe. I'm going to hide that wireframe. And when you pick turning, what am I going to pick? Cutoff. And you see it says select cutoff point boundary. It says that right there. I moved it into space so you can see it. Where am I going to pick? If I pick on the line, should I pick like over here on the midpoint or over here? That was bad, right? So you actually have to pick on the endpoint. You see that? So I'm going to press X. No. So I'm going to do cutoff, pick the endpoint this time, right there. Now, they're grooving tools. So I go all the way to the bottom. I might have a right-hand cutoff tool or a left-hand cutoff tool. I have a right-hand one. So we'll go right-hand, right-click. We're going to edit that. What matters on the part-off tools, do you think? What's the most important thing in this tool geometry? Thickness right here. This D, or this E, 125. And it happens to be the exact part-off tool we have. Most part-off tools are 1/8 inch. Now, we don't have this sweet little C angle in ours. We actually have 0. So we are going to make a nub at the end. If you didn't want to make a nub, you would have a left-handed part-off tool goes this way, And it basically has a little rake to it, so it's gonna go ahead and take the nub off first. We just have neutral part off tools, so we're gonna leave a little nub. I'm not too worried. So when I pick that, I'm gonna go to my holder. I don't change my holder. And on my parameters, I definitely need to make that 4. So it's tool 4. 2.5 thou. I don't want you going above 500 RPM to part off either. We don't need that thing spinning super fast and flying out of the lathe. Every now and then it hits the rubber pad, hits the spindle and it kicks. But like, so like make sure there's no chips in your rubber pad. Your rubber pad's not like angled towards the spindle. If it bop, I've had people put the rubber pad down on chips, so it's angled like this. It goes, and like, yeah, so just nice flat rubber pad on there. It won't dent. It'll be great. So when I hit check mark, I'm now going to use tool 4, the cutoff right. I'm going to go to cutoff parameters. With that, this is really cool, but it barely works. Do you see this back here corner geometry where it says chamfer? It'll put a chamfer in the back with the part off tool. You really need to groove a little bit out of the way first and then do it. This part off tool flexes when that does that, and you don't see your chamfer, but I'm going to put it on there anyway. But does that make sense? You groove away a little bit in the back, and you can put the chamfer on the back and then part off, and you'd have a chamfer on the back side of the part. I'm too lazy to set all that up right now, so we're just going to go ahead and just do it the way I'm showing you. So what we're going to do is we're going to hit parameters. We're going to go to width, and it's 0.025 and 45 degrees. Look, it puts a 3 thou top radius and bottom radius on it. You're not going to see it. It's the size of a hair. So now, do I just want to jam this part off tool right through it? What do you think?
Slow down.
What do we do with our part off tool to break chips? Peck. So what I'm going to do is I'm going to click this button that says peck, the radio button. It turns it on. Now I got to set up my peck settings. I can't just click the button. So when I hit peck, this would be very bad if you don't understand absolute and incremental. So we are going to basically use retract moves. Are we going to retract to absolute 0? In fact, retract amount 10 thou. What happens absolute 10? Where's it going? Students do this sometimes. Right down to 10 thou, and its first pass, it's already parted off for like it didn't even peck because you didn't incrementally retract basically at 10 thou. When you absolute, you go absolute to that position. So you can tell at absolute 1.5 if you wanted to come all the way out. But what it's going to do now, it's going to basically do little 10 thou pullbacks to break the chip and then go forward. It takes too long to retract all the way back out and go all the way back in, especially in slow rapids. So we could dwell. I don't need to dwell. My peck amount is definitely not good at 150 thou. It'll be all right there, but we're going to go basically 50 thou pecks. Sound good? So what it's going to do, it'll peck down. It's probably going to tell me it crashes when it does the chamfer. I tell you that, it's going to be okay. Nothing's going to crash. So when I hit check mark, yep. There we go. It collided with stock, but the stock's missing. We're good to go. You see how the stock's now not on the part? And if you look at this, what's this little radius? All right, let me go right here. Tool paths, parameters. Don't put those in there. You can do, it doesn't matter if you do or not, but like, it still says it crashes, but at least it took out those little arcs, right? But now, if it was me, honestly, it's not going to do the chamfer. Check mark. It doesn't crash when it says it doesn't do the chamfer because it's not trying to turn with the part off tool and run. It's running into stock, and I didn't clear the stock out of the way is what it is. You good with this? That was all it is. That's the whole project. So now, what we're going to do, because I showed lathe setup in individuals last week, I'm going to bring all 30 of you in there. We're going to pull it out. We're going to run this. Does that sound good? Like literally, because then you're going to do it on your own, and I feel that you're going to be good to go because I showed you setup last week. I'm still going to set up this week, but I'm going to set up with 30 of you in there. That way we can work on the rest of the lab here. So I would like you to simulate. Yes.
You want to stick.
I don't care either way. It's not gonna make it. I'm telling you right now. You can keep it on if you want to try it, but it's some people's parts. It's at least like a little edge break. Some people's it doesn't do it. So doesn't matter to me. It could be how they set up too, because you're touching off all your own tools, and your tools might be a little bit off 1-to-1. You're not seeing the chamfer. So, but what I'm gonna do is I'm gonna call it good there. I would probably go to the simulation. Simulation definitely shows you mistakes, right? I wasn't looking at you. Kind of. So it's all good. At least we're having fun, right? So to make it a slant bed, it goes back this way. To make it a tool room lathe, it goes this way. That's the only difference, like where the tool's oriented. So it makes the little blue lines for the chuck, just to make sure we're not going to hit it. And we're going to slow it down a little bit. We're going to press play. That's a bad. Good thing we simulated. I don't know if it's actually going to do that. I think we'll look at it here in a second. We made a bullet. I actually don't know what did that. So let's look. I don't think it does that. It's literally retract from one to the other. Did we name all the tools 1, 2, 3, 4? Hold on. I don't think it does that. I think that's a mistake. I really do. Let's watch it again. That's kind of weird, isn't it? I didn't see it on the stock or anything like that, right? So when that happens, you definitely want to look at that kind of stuff. I'm just kind of curious because it was like right here, right? That was the retract out of the rough. You see that? So it was right, what? Yeah, it was right here. Hold on, let's go. It's that move right there from where it transitions tool paths. I don't think it's going to do that. Let's look at the code. How does that sound? So that is just really weird though. It might do that. Let's go back and look at the toolpath first. I keep forgetting I'm on video. So let's go over here. Let's go from the rough. So let's go to parameters. Let's just look at lead out. There's 45 out. We're good to go. Comes out. And then when it comes here to finish, I'm just going to hit perpendicular there. I honestly don't think it's going to do it. This is weird. Okay. So how we're going to tell that? We're going to go like that. We're going to go hit G1. We're going to hit check mark. We're going to, that's 336. So spring. And 335. This is week 9, huh? So project 3, S24. So what's going on? We got to do something to the code too. I'll just let you know that. So right now, why am I getting rid of this? Too long. It could be. Then we're going to call this 00337. Sound good? Then we are going to look at our X values are good. Can you close that door? It's really bad. So we look at our X values. Thank you. Why does it come across negative X here? And why is that number 0.0625? 0.03125 is 1/32 of an inch, right? And you double that because it's diameter. So it's going across the center of the nose radius value. That's the only negative X you should ever see in your program. Is from facing, it should come slightly across center line for the nose radius value. Everything else should be positive X. Please look at your code before you actually go to the machine. It's gonna save you some time. Sometimes some students have their stuff flipped. I check to see if the lines look good. I don't really check these that well. It's the end of the year, I'm really busy. I look at them, I double check, but every now and then you're just off on your X's or whatnot, or your Z's. So, but I look to make sure the code looks good. Like the line, I make sure lines look good. That's all I look at. So now, when it goes across here, it comes over here. What are U, V, and W in lathe programming? You watch the video, you know. Incremental, right? So why would this be bad for our lathe? Only one thing is bad in there in our lathe, for our lathe. U is for which axis? V is for which axis?
The Y.
Oh, Y. Do we have a Y-axis lathe? No, so the only thing you have to erase from your post is basically V0. What I'm gonna do is, because you see what it's doing anyway, it's G28ing anyway. I'm just gonna erase U, V, and W. I don't need any incremental in my program. So what it's gonna do between tool changes, it might make you feel better. It stops the spindle and goes home. Yes.
What happens if you don't delete that?
It's gonna throw an alarm, and when it goes to hit that line of code, it's the machine's gonna alarm out because it doesn't have that access. It's gonna try to make the move and it can't because it doesn't have that access. So it's gonna say code, like, I don't know what it says exactly. But it's not gonna hurt anything if you didn't take that out. You're just gonna have a red light. So now how many times do you think that occurs? How many tools do we have? 4. So at the end of every tool, you look at that. So now right here, this is my rough. Does everybody see that? So at my rough, let's see where it goes. Let's see if it's going to crash this thing. It comes at X of 1.55 and Z negative 3.93. Does everybody see that? So that's where it leads out. That's its 45-degree lead out. G18 is a plane. We're not worried about that. We're always in the G18. Then it changes my speed and feed, right? Now it comes over to G00Z 1.0. Then it goes to X0. Then it goes to G1 Z0. We're doing good so far, aren't we? I don't know why that shows crashing. It's not going to crash. Promise you. Does this make sense how I figured that out? I just looked at the lead out move right here. Then I saw where it was going. It rapids back to 0.1 in front of the part, goes back down to center line. In fact, I'm going to make it go to X of a negative. Negative 0.0625, right? So it just takes care of the insert. I didn't do that on my face pass. And then literally we're good to go. You don't have to do that whatsoever. In fact, I'm not going to change it. I'm gonna leave it at 0 to prove to you. Cool. All right. Now, what do I erase down here? UVW. So you can search for any UVs or Ws and then you'd be good. So now this one is the grooving tool. Does everybody see that? It's grooving a bunch. Then it finished grooves right there. It's making the chamfers. And what do I erase at the end of that tool path? UVW. Let me tell you one more time. It's like a broken record. Now we're cutting off. So these are just the plunge X moves. See? Bloop, 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 bloop. Now, what do I erase? UVW. We're good to go. We press save. I don't have a memory stick. Anybody got one? Yeah, fail on my part. I'm bringing the whole computer. So let's go to the lab. I'm going to show you the setup now. Then it's open lab for you. Let me actually go back to the PowerPoint real quick, actually, and stop the video. That would have been really bad. I almost hold on. So basically, from here on out, it's homework assignment. It's a lab experience 7 to set up the lathe. So if you're watching the video, we'll see you in the lab. So we'll stop that recording.